All right, here's a demonstration of a stoichiometry problem going from starting with grams and ending up with grams. That is applying the skill that we've learned with mole fractions to real-world quantities. We don't measure moles, we measure grams. So can't measure in moles. Relating moles of different quantities through the coefficients in a balanced chemical equation, as you've been doing, is only the first step. We need to connect these quantities to something we could actually measure in the lab. The thing we most commonly measure is mass in grams. So it's now a three-part problem. We're going to take the given in grams, and we're going to find the moles of that substance. The balanced chemical equation relates moles of different things. So next, we use the balanced chemical equation to relate moles of the given to moles of what we want. Once we have the moles of the things we want, we can convert that to grams for the answer. So our algorithm is mass of given to moles of given. Then we use the balanced chemical equation and the mole fraction to get the moles of the thing we want, and then we convert to the mass of the thing we want. So there are three conversions, basically three conversion factors in this problem. So let's do an example. A process by which zirconium metal can be produced from the mineral zirconium-4 orthosilicate, ZrSiO4, starts by reacting it with chlorine gas to form zirconium-4 chloride. So I just put all that stuff in as a reminder that, yes, you did learn nomenclature at one point. Orthosilicate is another polyatomic ion that you didn't have, which would be SiO4 minus 2. All right, or sorry, SiO4 minus 4, because their zirconium is zirconium-4. All right, so here's the equation: zirconium-4 orthosilicate plus 2 chlorine gas goes to zirconium-4 chloride plus silicon dioxide plus oxygen. So what mass of zirconium-4 chloride can be produced if 862 grams of zirconium-4 orthosilicate reacts with excess chlorine? Here's our equation. What is our given? Okay, our given is 862 grams of zirconium-4 orthosilicate. What are we asked about? What do we want? We want to know the mass of zirconium-4 chloride formed. So we're given 862 grams zirconium-4 orthosilicate. We want grams of zirconium-4 chloride. Let's write our algorithm. Okay, we're going to start with grams of zirconium-4 orthosilicate. We're going to convert that to moles because we have to have moles in order to use the balanced chemical equation to relate one quantity to another. Equations are in terms of either atoms and molecules or moles. Got to get out of grams, got to be in moles. So convert to moles. Then we use the equation to relate moles zirconium-4 orthosilicate to moles of zirconium-4 chloride. And once we have that, we're almost home free. We just convert that back to grams of the product zirconium-4 chloride. All right, so here we go. We have our givens, our given at the top, what we want. We have our algorithm. We're going to keep this up here as we work the problem. All right, so the things we're going to use to convert grams to moles, we're going to use the molar mass. Okay, we're going to completely ignore the equation and everything. Grams to moles, the thing that connects those is molar mass. Moles of zirconium-4 orthophosphate or orthosilicate to moles of zirconium-4 chloride. That's where we're going to use the mole fraction from the balanced chemical equation. And on the end, moles back to grams is going to be the molar mass of this product, zirconium-4 chloride. So in the middle, mole fraction. All right, so let's find these molar masses. The molar mass of zirconium-4 orthosilicate is going to be 91.22. That's the mass of zirconium, plus 28.09 for the silicon, plus 4 times 16 for the oxygen, and that gives us 183.31 grams. So our conversion factor for the going from grams of zirconium-4 orthosilicate to moles zirconium-4 orthosilicate is going to be 1 mole ZrSiO4 over 183.31 grams ZrSiO4. All right, now this other molar mass, zirconium-4 chloride, is going to be 91.22 grams for the zirconium, plus 4 times 35.45 grams for each chlorine. and that's going to give us 233.02 grams. And that's going to give us a conversion factor. Since we're going 2 grams, grams are going to be on top. It's going to be 233.02 grams zirconium-4 chloride over 1 mole zirconium-4 chloride. All right, how about this mole fraction? Well, we're going to use the balanced chemical equation, and that is zirconium-4 orthosilicate. One of those plus 2 chlorines goes to 1 zirconium-4 chloride plus 1 silicon dioxide plus 1 oxygen. So we can see that 1 mole zirconium-4 chloride is produced for every 1 mole zirconium-4 orthosilicate that reacts. Our mole fraction is thus going to be 1 mole. We're going to put the thing we want above the thing we have. 1 mole zirconium-4 chloride over 1 mole zirconium-4 orthosilicate. So we now have our 3 conversion factors. We have our algorithm showing what we're going to do, and we can get going with our calculations. Start with a given, 862 grams of zirconium-4 orthosilicate, and we're going to multiply by our first conversion factor, which is our molar mass of zirconium-4 orthosilicate, and that is going to give us moles of zirconium-4 orthosilicate, 4.702 moles. So next, we need to take that number of moles and find the moles of zirconium-4 chloride formed. Our conversion factor is going to be this mole fraction. We already found the mole fraction, so we're going to start with 4.702 moles zirconium-4 orthosilicate, multiply by 1 mole zirconium-4 chloride per 1 mole zirconium-4 orthosilicate, and that is going to give us, of course, 4.702 moles of zirconium-4 chloride. All right, now we have moles of our product. We're almost home free. We just need to get that back to grams. The connection, again, is going to be the molar mass. So we have 4.702 moles of zirconium-4 chloride, and we're going to multiply by the molar mass that we found, 233.02 grams zirconium-4 chloride per mole of zirconium-4 chloride, and that is going to give us 1,090 grams zirconium-4 chloride. Now, there's a slightly shorter way to do this problem, and it's a procedure worth learning because if you go on and do anything in chemistry, an awful lot of teachers and students and everybody else will set it up this way. So, notice after we'd finished our first conversion and we got moles of zirconium-4 orthosilicate, we took the number we got out of that first calculation and we then put that on the second line and multiplied by our next conversion factor. Okay, but this number is equal to this product. So we're just going to leave out this step, and we're going to take this second conversion factor. Instead of multiplying by 4.702 moles zirconium-4 orthosilicate, we're going to multiply by this expression that is equal to that, all on the same line. Okay, then, now that came out to 4.702 moles of zirconium-4 chloride, and then we multiplied by the molar mass of zirconium-4 chloride, but again, these numbers are equal, right? This number in blue is equal to this expression. So instead of multiplying this number times this new conversion factor, we can just take this new conversion factor and multiply it by that expression up there. This is mathematically identical to what we did before. We just don't have to get out the calculator till the end. Plus, we can do my favorite thing of canceling out things. So here we have grams zirconium-4 orthosilicate on the top and on the bottom. Oops, I crossed out the number. I just meant to cross out the grams. And here we have moles zirconium orthosilicate crossing out on the top and on the bottom. Here we have moles of zirconium-4 chloride crossing out on the top and the bottom. We are going to end up with units of grams zirconium-4 chloride. 1,090 grams zirconium-4 chloride. And there you have it. That was applying stoichiometry and conversion factors to start with grams, get to moles so that you can use the balanced chemical equation, apply the mole fraction from the balanced chemical equation, and then convert back to grams. That wasn't